Yesterday we learned that there are different types of days. Monday, Tuesday, no, just kidding. There's sidereal day, one rotation. There's solar days, one rotation, plus a little bit more to get back pointed directly at the sun. Well, if there's different types of days, there are also different types of years. All right. In your science journal, I would like you guys to write down this little T-chart. There's what's called a solar year, or a tropical year, and then there's what's called a common year. If you look at these pictures that you see on the screen right now, one has to do with the sun, one has to do with the calendar. The sun and the calendar don't match up at all. All right. This is going to hopefully help answer that question of why we have leap years. So you need to know the definition. You need to know how long a solar year is and a common year is. Then you need to have a sketch. The reason that it's different is that the Earth does not orbit a certain amount of times very nice and neat as it goes around the sun. So if this is our little alignment, we move the sun so that you can see, and the Earth goes around, it doesn't rotate and get right back where it started and be facing in the same direction. Instead, what happens is as the Earth is orbiting around the sun, it will get back to the same spot in its orbit, but all of a sudden it's pointed in a different direction. It's not an even amount of days to do one orbit.
To understand leap year, you have to know this one fact. Earth rotates 365.24219 times during one full orbit of the sun. That's right, a year is not 365 days. It's 365.24219 days. Which means our 365-day calendar is off by a quarter of a day, or about 6 hours, every year. It's pretty annoying. Julius Caesar thought so too. Back in 45 BC, he came up with a solution. For 3 years, we ignore that extra quarter of a day. Then every 4 years, we add those 4 quarter days back together and stick an extra day at the end of February. Without that leap day, the gap between the calendar year and the true year would gradually increase. After 100 years, the calendar would be off by about 25 days. So why does this matter? Billions of years ago, something smashed into Earth and knocked its axis about 23 degrees. And thus were born the seasons. Winter when we're tilted away from the sun, and summer when we're tilted toward it. And we're used to these seasons lining up with our calendar. It's handy for all sorts of record keeping. But without leap year, our calendar would become disconnected from the seasons. After 700 years or so, Christmas would show up in the middle of summer. We'd have Thanksgiving in the spring, St. Patrick's Day in the fall, and Labor Day in the winter. Chaos. It's still not a perfect system, though. Leap year actually overcorrects slightly, so every 100 years we skip a leap day. But that puts the calendar slightly behind again, so we skipping leap day every 400 years. And even still, after a few thousand years, we'll be off again by a day.
To fill out our T-chart, the definition of a solar year is one exact 360-degree trip around the sun. A common year is going to be hooked up to our days. It's going to be hooked up to how many times Earth is spinning. It has nothing to do with an orbit around the sun. It's how many spins does the Earth take. In order to go one full trip around the sun, that is 365.24 days. So it takes 365 spins plus a little bit more of a spin to get back to right where we started. Our calendar, though, is hooked up to how many spins our Earth does. How many days does it take? Normally it takes 365 days. The problem, and the Earth should be spinning this whole time, it's just hard to do. The problem is that after 365 days, and this is going to be exaggerated, as you start here, as you go around, after 365 days, the Earth is not back where it started in its orbit. You have to go a little bit farther in order to get back to where you started. Or you could have a leap year, where you go 366 turns, and that counts as 1 year. Okay? Has nothing to do with our common years, our days, has nothing to do with a full orbit around the sun. It has to do with how many spins we are taking. It's this solar year, or what's known as a tropical year, that has to do with a full 360-degree orbit around our sun. So why do we have leap years? Well, the reason is that one orbit and 365 spins are not the same amount of time. You have to go 365 spins and then a little bit more, that 0.24 of a day, to get back where you started. And if you don't do that, well, then this is the end of a year, 365 days. The next year, the Earth will be here after 365 days. The next year, the Earth will be here in its orbit. Remember, it's tilted, and that's what's causing seasons. The next year, the Earth will be here, then here, 365 days later here, and all of a sudden, it's now winter time in July, and it's summertime in December. So instead of having the calendar and the seasons become completely off, what we did is we added an extra day every 4 years, so that instead of being here and then here, we add an extra day, and now we're lined up again. It's basically to keep our orbit and our spinning all lined up.
Orbits the sun once every 365.2425 rotations. So if your calendar has a whole number of days, like 365 or 366, then you're counting either too few days or too many. And if you're counting wrong, then things like the solstices, the longest and shortest days of the year, which always happen at the same point in the Earth's orbit, will move around the calendar. That makes it a little tricky to plan for events that you want to happen on the same day every year, say a solstice celebration. And as if that wasn't complicated enough, a lot of ancient cultures like the Babylonians, Chinese, and Romans used calendars based on the moon. But the behavior of the moon, again, has nothing to do with our rotation or our orbit. The moon goes through a little more than 12 cycles, each a little more than 29 days in the time that it takes for the Earth to go around the sun. And that means they had a similar problem. 12 lunar months a year is too few, but 13 lunar months in a year is too many. So most people using a lunar calendar would have 12 months most years, but then they'd add an extra month every couple of years to keep things like harvest around roughly the same solar date. Then there were the Romans, always trying to keep things interesting. Instead of having a system in place for how often there should be an extra month, they left it up to their highest religious authority, the Pontifex Maximus, which kinda worked for a while, at least until Julius Caesar came along. The Romans thought adding those extra months was super bad luck, so they didn't want to do it while they were at war, and Julius was at war all the time, so the calendar got way off from where it should have been. So eventually Caesar decided that the Romans should just use a brand new calendar that relied on a set system of when and where to add extra days. And that's how we got the Julian calendar, which Western Europe and Christian churches used for a really long time. Most Julian years had 365 days, but like we said earlier, the year is about a quarter of a day longer than that, so every fourth year got an extra 366th day. Seems like a good fix, but things are not that simple. The 4-year system ends up slightly overestimating the length of the year by about 10 minutes, something the designers of the Julian calendar knew about, but they decided it wasn't worth complicating the calendar over. It's 10 minutes a year. What could go wrong? Well, 10 minutes a year over a lot of years can really add up. By the late 1500s, around 1600 years after Caesar, the calendar was about 13 days off from where it should have been. That's when Pope Gregory XIII, the Pontifex Maximus of the Catholic Church at the time, decided that the Julian calendar needed an overhaul. So he put together the Gregorian calendar, the one that we still use today, which is really just the Julian calendar with a couple of changes. The Gregorian calendar's new rules were every 4 years, add an extra day. Except don't add it when the year is divisible by 100, except actually do add it if the year is divisible by 400. So 1700, 1800, and 1900 weren't leap years because they were all divisible by 100, but not by 400. But the year 2000 was a leap year since 2000 is divisible by 400. And of course 2016 is a leap year as well. If we were still using the Julian calendar, 2016 would still be a leap year, but the calendar would now be behind by 16 days, so this video would have been uploaded on February 13th, 2016, not February 29th, so it wouldn't have made any sense. But the universe is complicated and does not care about our calendars, so the Gregorian calendar is still a little bit too long. We will add a day about every 7,700 years. But don't hold your breath for a new calendar. The Gregorian calendar was only introduced when the Julian one was 13 days off from the true date, and that won't happen to the Gregorian calendar for another 100,000 years or so.
What I'd like you guys to do is make another Venn diagram. On one side, I would like you to put a solar year, or a tropical year, and on the other side, a calendar year. Go ahead and fill that out in your science journal. Also tell me why there is a difference between a solar year and a calendar year. If I was going to fill this out, what would I put? Well, both of them have to do with the Earth orbiting around the sun, but neither one of them is exact. So they have to somehow match up. And we do need to use both. All right, one full orbit that will get us to the same season, and 365 spins that will keep the time. Like noon will still be noon, and 2 in the afternoon will still be 2 in the afternoon. What do they have that's different? Solar year, one full orbit, that is 365.24, whereas a common year is 365. The problem is you don't get back to the same spot in your orbit. A solar year uses the Earth's orbit, or the Earth's revolution, whereas a common year is going to be how many spins, how many rotations, how many days does it do. Common year is what most people think of as a year. If you go out and ask somebody how long is a year, they're going to say 365 days. They're not going to say 365.24. So they are thinking of it on a calendar, hence the calendar year. They're not thinking of it astronomically, one orbit around the sun. As an exit ticket, I want you guys to figure out what would happen if we did not have a leap day every 4 years.